So for measurement, the first thing that we're going to start with is conversions. So this is different from grade 9. Again, it's quite straightforward, though. The steps are really clear. And the way that we're going to do it, like there's different ways to do conversions. And quite frankly, with technology these days, it's really, really easy to do it. You can just like literally ask your phone how many kilometers is 150 feet, or how many meters is 150 feet, and your phone would probably verbally be able to tell you. And Google has a feature where you type it in and it pops right up. That being said, we are still going to look at the sort of way of doing it by hand. And this is a method that will always work. And it's the same every single time. And then tomorrow we're going to do some slightly more complicated conversions. And the method that we're going to use today is going to really help with that. Okay? Anna. Absolutely, yes. You do not have to memorize any of these conversion factors, okay? So but hang on to that sheet, because I'm not going to cut a bunch of extras and have extras, so try to hang on to yours. But on a test, I would either let you use the sheet, or on the test, I'd just give you the ones that you need, kind of thing. Okay. All right, so we're going to do a couple of simple ones. And we're going to use a process that we have used in the past. So it'll be familiar. It's going to review some stuff that we've already done. It's going to help us with that the sort of cycle assessment that I was just talking about. That's going to come up later this week. Okay, so it's good stuff. There's two types of measurement systems, two main types. There are sort of others as well in some ways, but there's two main types in the world. Metric, which is one that was designed later on in like human society. And it was designed with purpose. It was designed so that things made sense, so that all the pieces fit and everything lines up really nicely. So when you look at your conversions chart at the top, it's got all the metric system for length, mass, and volume. And you can see that everything is ones and zeros, okay? And that makes the math really easy to do. You've done this before, and there are tricks to this. We're going to do it the same sort of slower way, step by step, just to see it in action. But in a pinch, you could use, like if you understood the metric system, you could do it much more quickly. That's the whole point of the metric system, just by moving the decimal around, right? That's the whole idea. So 3 kilometers is 3,000 meters. You just move the decimal 3 places. 1 kilometer is 1,000 meters, so it's really easy to do. But there's another system called the imperial system, and the States still uses it, and there's like 1 or 2 countries only in the world that still use it officially. Everybody else has moved over officially to the metric system. But there's still, partly because in Canada we're so dependent on the States, but also there's just a lot of things that are ingrained with the imperial system, like measuring lengths of wood to build a house or that kind of thing. Lots of those things are still measured in inches and feet and yards and that kind of thing. And so it's common to hear that sort of thing in Canada. A lot of people know their height in feet and not in meters or centimeters. A lot of people know their weight in pounds, not in kilograms. Temperature, some people still use Fahrenheit. Interestingly, I think a lot of people use Celsius for like temperature outside. But then if you're cooking, we almost always use Fahrenheit. And if you're like making, something from a box, it'll say 350 degrees Fahrenheit on the box to set the oven to. So it's kind of a mix of both. And I'm sure you've thought of others. So we're going to look at a little bit at metric, a little bit at imperial, and how to convert between. If you know the conversion, the steps are always the same. So with this paper, the steps are always the same. But it's important to think about, are you dealing with metric? Are you dealing with imperial? Which one is it? Okay. Any questions about any of that? So the first one we're looking at is feet to inches, which is all imperial, okay? And does anybody know how many inches are in a foot? Kevin? 12 inches in a foot. It should say that on this sheet somewhere under length. 1 foot equals 12 inches. You can see it there. but a lot of you probably know that anyway. So we're going to do it the same way. We're using proportions just like we did before. This is what it's going to look like. We're going to, even in our head, ideally, say it the same way with proportions we're doing before. So how many inches are in 5.5 feet? I'm not actually asking that. Hold on. Remember, so when we do a proportion, so you want to copy this down. When we do when we do a proportion, we did these earlier, right? And we always try to put x on top, so we're going to start with that. You have to understand what you're trying to find. You're trying to find the number of inches. We use 2 tick marks for inches and 1 tick mark for feet, or you can say feet. So how many, that's my x. I ask that question. How many inches, put x on top, is 5.5 feet if, and then you got to get the units the same. Okay, so I put inches on top. 12 inches is 1 foot. And now it doesn't matter where this proportion came from. I always solve proportions in the same way. So I'm going to move this out of the way. How am I going to solve this one? Ethan? Kind of. There's a bit of a safer way to do it. That is a way kind of that works, but what's the way that we've done it in the past? Brianna, what were you going to say? Yeah. And how am I going to do that? If I'm dividing by 5.5? Yeah. So in fact, this is going to look a lot like cross multiplying. Remember, I worry about that statement. But essentially, it's going to be the same idea. So I multiply by 5.5 on both sides. Gets rid of the 5.5 on this side. And you wouldn't have to rewrite this, but this ends up being x equals 12 times 5.5 divided by 1, which will do nothing. But in some cases, that might not be a 1. It might be something else. Usually, there's a 1 involved. Not necessarily always. And I'm telling you, people get a little bit cocky when it comes to doing this stuff, and they want to do the shortcut. And for the most part, they understand it. They're like, why do I have to use a proportion? I know you just multiply by 12. So in some cases, you multiply. In some cases, you divide. But I'm telling you, if you do that, first of all, I'm going to want to see you at least once or twice set up a proportion to solve it. And in some cases, you're going to get it wrong. You're going to divide when you're supposed to multiply or multiply when you're supposed to divide. Every year I see that happen, where people think they get it, and they get most of them right, but they get a few of them wrong because they get it backwards. And when you set up a simple proportion, it only takes one extra step anyway. It shows your thinking, and you'll never have to worry about wondering whether you multiply or divide. The proportion figures that out for you. Okay, so what is 12 times 5.5? 66? And 66 inches. Whoops. It is pretty easy. These questions are pretty simple, but I want you to not just be able to get the answer, also learn how to use proportions to solve it. And then tomorrow it gets a little bit trickier because we add a twist to it. We don't just do straightforward units, and then we kind of need proportions. Okay, why don't you try to set up the next one? So you're asking yourself that question, like, how do you start with the first part of the proportion? Where does the x go? How do you get the x on top? That kind of thing. You got to find the conversion factor on the sheet to write the rest of it, the proportion. Adam, you with us here? So how do I set up the first part of the proportion? Ethan?
X over 185.
Awesome. How many ounces is 185 pounds? So ounces on top, pounds on the bottom. What's the conversion? 16 over 1. So that means 16 ounces equals 1 pound. And there it is right there. 16 ounces is 1 pound. Be careful. There's two kinds of ounces. This is another problem with the imperial system. They have ounces in mass, which is a weight, but they also have ounces as a volume. So that's like if you have a can of soup or something, it could be measured in ounces. That's not a weight. That's like fluid ounces. And they're slightly different. They both do have 16, but one's to a pint and one's to a pound. Like they're different. When you see fluid ounces, that's what it'll look like as a short form. Okay. Whereas ounces is just OZ part typically, but you want to make sure you understand that there's two sort of different ones. Ethan, you had your hand up? All right, so what do I do in this case? Looks like we're going to multiply by 185. So we're multiplying again. $16 times 185. 2,960, and that is ounces. So 185 pounds, that's like maybe the weight of an adult. And apparently they're about 3,000 ounces. Not something you would usually measure an adult's weight in. But any questions? Pretty straightforward, right? Let's try a couple more. So go ahead, see if you can try both of those all the way to the answer. You can't use any of your own little tricks, like I always put the X here, or I always put the 1 here, or I always do this, or I always do that. You have to think about it the way we've talked about it. You do want your X on top, but you want to set it up that way, and then you have to think about units. So in this case, how many yards is 6.5 feet? If yards is what I'm looking for, yards is on top. When I get the conversion factor, I still need yards on top. That's what I mean by that. So when you set this one up, it's a little bit different. X over 6.5 equals 1 over 3. And like I said before, some of these are easier, some of these are trickier. And sometimes your brain plays a trick on you. 6.5, so I'm going to multiply both by 6.5. And I end up with, so those guys are gone, but I end up with X equals 1. Again, that doesn't really do anything, but times 6.5 divided by 3. So X is 6.5 divided by 3, which is what, Ethan?
I rounded it to 2.2.
Nice, 2.2. 2.2 yards, very good. Okay, try the next one. How many miles is 3 yards? Miles is on top. Yards is on bottom. So I find the conversion factor on my sheet, and it is right there. So if 1 mile is 1,760 yards. So again, multiply both sides by 3. Those guys are gone. X equals 3 divided by 1760. I don't know why anybody would want to do this conversion. It really obviously complicates things, but who knows? Let's take a look at it. Typically, it's going to give us, this one doesn't in the lesson, but it's going to give you instructions in a question, round to 1 decimal place, round to 2 decimal place. So you would just have to follow instructions. Let's just take a look at the answer and see if we can make sense of it. So 3 divided by 1760, and convert that to a decimal. You're not going to round it to 1 decimal place because that would look like 0. We're not going to round it to 2. So in this case, we'd have to go to at least 3, and I'm going to put 4 because why not? This is not something that you would normally need to worry about, but it's an interesting idea where people often say, like, what do I round to? What do I round to? Where in real life, you got to round to something that makes sense. It's like up to you. So I just picked a couple of these decimal places because that gives me a good indication of what the answer is like. Very, very small. Does that make sense? Once again, it is so important when you're doing these that you think about your answer. Does it make sense that anybody explain why this makes sense? Brandon, what do you think? Like, that's a really small number. Some people might think, that I must have done something wrong. Ethan, what do you think?
Well, it's just showing that miles is greater than yards.
Yep. So 3 yards is about how long? Like from the edge of this desk to the edge of that desk. Is that even close to 1 mile? No, miles are long. So it's 0.0017 of a mile. It's a tiny, tiny, tiny little bit of a mile. That makes sense, right? And you can think about that. Should the number be getting bigger or should it be getting smaller? What if it was 3 miles to yards? Well, then you would have a whole bunch of yards because you need a whole bunch of yards to fit into 3 miles, right? Think about those sizes because that will help you understand it. Okay, so here's what we're going to do. I'm going to put up the worksheet. You can do questions 1 and 2. I'm going to give you about 5 or 10 minutes to try a bunch of those on your own, and then we're going to come back and try a couple of different kinds of questions.